Good morning, afternoon, or evening, whenever you're watching this video. This is Solving Radicals Part 2, part of the Unit 6 square root functions. Today we're going to continue to solve for variables or variable in a radical equation. Had a typo there. Hope I fixed that before you guys see it. The plan is to go ahead and we're going to start with our lesson on solving radicals. That's what this video is. I'm going to start putting these links also available on the PowerPoints themselves so that you guys can click back and fast forward, rewind on different problems. That way you can get the help that you need. All right, so this lesson is definitely one that you're going to put in your paper notebook. I don't think any of these should be on Google Slides anymore as far as working them out. So first of all, let's talk about a radical equation. So that's an equation in which the variable appears under the radical sign. Okay, so we've done some practice problems with that before. Now remember, and always remember, we need to first isolate that square root and then square the square roots, and because the square is the inverse of the square root. All right, so for our very first example, we've already done a few of these where we have to isolate the radical. These are going to be some special situations where we may end up having to FOIL or having to factor because there might be two problems. And to tell you the truth, you're going to end up with some extraneous solutions that we need to double check and make sure that it's going to end up being a solution. And a lot of students sometimes forget to double check. So let's go ahead and get started. We're going to go ahead and solve x for example 1. So we have 3 equals x plus the square root of x minus 1. And first step is always to go ahead and isolate that square root. So we need to make sure that everything's away from that square root. Right now it's not. So I have to subtract x from both sides. I'm left with 3 minus x equals, and I put that in parentheses kind of as a, it doesn't matter. You can have it in parentheses. You don't need it in parentheses right now. I was kind of setting it up for the next step. And we have the square root of x minus 1. Notice we have the square. In order to get rid of the square or to eliminate it, we need to go ahead and simplify it out by squaring it, because the square of a square root simplifies completely out. You're left with just x minus 1 on that side of the equation. Whatever you do to one side, you must do to the other. Binomial squared. Remember, this is not just 9 minus x squared. Remember, you need to multiply it out, either using FOIL or box method, your choice, whatever you like to use. I prefer FOIL. So here we go. 9 minus 3x plus x squared equals x minus 1. Simplify like terms. So we would be left with 9 minus 6x plus x squared equals x minus 1. I'm going to subtract because I noticed that in order to solve for x on this one, and we have an x squared, we are going to have to factor. So in order to factor, we need to go ahead and set everything equal to 0. So we're going to go ahead and subtract x and add 1. That's going to become 10 minus 7x plus x squared. Some of you guys, that might be driving you nuts as far as the way it's written. You can go ahead and rewrite it so that it's in standard form. X squared minus 7x plus 10 equals 0. So now we can go ahead and factor that. Looking at a being 1, we can jump straight to our binomials. So what are the factors of 10 that add up to give you negative 7? Think about that. That would just be 5 and 2, but because it's negative 7, both of those are negative. Equals 0, and then to find those values, you would set them both equal to 0, so then you would end up with positive 2 and positive 5. So those are our solutions, but remember, one of them is an extraneous solution, so we have to figure out which one is by checking our answer. So when we check that, we're going to plug it back right into the original equation, not some simplified version that you've come up with, because sometimes you can make a math mistake. All right, so we end up with 3 equals 2 plus the square root of 1. 2 plus the square root of 1 is 3 because the square root of 1 is 1. So 2 does work. Let's go ahead and take a look at 5. So we have 3 equals 5 plus the square root of 5 minus 1. That just becomes square root of 4. Square root of 4 is just 2. We have 7 equals 3. They don't equal each other. So 5 is not a solution for this equation. It's actually the extraneous solution. And mathematically, when we think about this, and I'm just going to draw a parent square root. What happens is, and I need to draw a square root that actually has a vertical shift because we have 2 solutions. And what happens is we need that positive and negative x value. So when we reflect, we're going to end up with either a positive or negative x value depending upon what's going on. And it would be an extraneous solution. So like this and this, we would end up with this solution, but we'd also show up with this solution. So be careful. We don't want that negative radical solution. We only want the positive. And that's why we only have one solution. And we'll talk about that with regressions lesson coming up next. All right, let's go ahead and take a look at our next problem. When we have the square root, look, there's 2 radicals on the same side of the equal sign. Looking at this, I want you to think about how you could get rid of that radical, because it says make sure the radicals are isolated, but in this case we can't always isolate the radicals, because if I move one of them over, then we would end up having 1 plus or 1 minus, and this one might turn into a crazy one, and it is going to be, but we're going to go ahead and move one of those radicals over. So we're going to subtract the square root of x squared plus 3x minus 3. Whoop, not cubed. On both sides, this becomes 0. We're left with just the square root of x squared plus 5x plus 6, not plus, minus, equals 1 minus the square root of x squared plus 3x minus 3. All right, so looking at this one, we do need to get rid of the radicals before we can do anything else. This one's a little bit more trickier though, because we have that 1 going on. That constant is going to get in the way of things. So when we square this side, life is good. We're left with x squared plus 5x minus 6. On the other side though, because we have 2 terms, we are going to have to FOIL this out. Okay, and then when we do FOIL this out, we are still going to be left with a radical that we're going to have to take care of again. All right, so this problem is going to get kind of crazy fast, and you're going to be like, why do I need to know this? But let's take it one step at a time. So I know it's going to end up being 1 minus the square root of x squared plus 3x minus 3. I'm just rewriting that again like we would normally, but I'm taking a shortcut. Here we go. As far as not rewriting that this is a square. Okay, so let's go ahead and start this off. So now we're going to end up with 1 times 1, which is just 1. 1 times this entire radical, but remember it's negative. And then we have another negative square root x squared plus 3x minus 3. This is getting in the way a little bit. Whoops. So I don't want you to think that there's a line over that. Minus 1 square root of x squared plus 3x minus 3. Okay, and then on our very last one, we're going to end up with the radical times the radical, which the radicals would cancel out, and you would just be left with positive x squared plus 3x minus 3, because remember it's the radical squared. Okay, a lot going on right now. So what we're going to do now is this and this, these are common, or like terms. So we're going to take -1, the coefficient in front, minus 1. That would just give us 2. But keep the radical on the inside. Out here, we can go ahead and combine the 1 and the -3. Okay, and that's going to end up just being, I'm going to erase it from here. That's just going to end up being -2 plus x squared plus 3x. Just finish up the terms that are at the end. Here we go. Crazy problem so far. Now, remember we still have a radical and we need to go ahead and isolate it again because we need to get rid of another radical, which is right here. So what we're going to do is get everything away from that. So we're going to subtract x squared. I'm just going to subtract it from this side. We are going to subtract 3x and add 2. Alright, so that way these are removed from that side, and then we're left with only 2x minus 4 equals -2 square root x squared plus 3x plus, I'm sorry, minus 3. Okay. Because of the coefficient, I'm going to go ahead and, of -2, I'm going to go ahead and divide both sides by -2. This becomes -2x, not -2x. It becomes -x plus 2 equals the square root of x squared plus 3x minus 3. Whew. Now we've got that radical isolated. We need to go ahead and continue working on it. If I look back, oh my gosh, it looks crazy. You might need to pause the video at some point just to go ahead and catch up if you're just watching this. That is fine. So in this case, we're going to go ahead and square both sides to get rid of that radical. Now we're left with x squared plus 3x minus 3 equals -x plus 2. Whoops, squared. So remember, we need to go ahead and square that out. So that becomes x squared minus 2x minus 2x plus 4 equals x squared plus 3x minus 3. Woohoo! We have gotten to a point where all radicals are gone, so we can go ahead and start moving things over to one side or the other. It does not matter which side you move it over to. I'm going to go ahead and subtract the side that's already simplified. And plus 3x, nope, minus 3x, and plus 3. Okay, so this cancels out on that side. Over here I'm left with, this cancels out, so I'm left with -2 minus -2 is 4. 4 minus -4 minus 3 is going to give you -7, plus 7 equals 0. And we just need to solve it. So I could subtract 7 to this side, which I didn't even need to subtract that over. I wasn't observing that the x squareds were going to cancel. But when we divide by that -7, x is just going to equal -1. Okay, still not done. We need to double check that -1 will work in our equation. Okay, I'm going to zoom out just a touch. Okay, so if I have -1, I'm going to go ahead and use a different color because you are going to check. Okay, I'm going to substitute it into the original equation. So we have 1 squared plus 5 times 1 minus 6 plus 1 squared plus 3 times 1 minus 3. Those are going to isolate, or not isolate, become 0. So we're left with square root of 1 plus, well, which is 1. 1 plus 5 is 6. 6 minus 6 is 0, so that's just 0 equals plus 1. Hey, 1 equals 1. We are good to go. Yay! Alright, so this does work out. This is a solution. that we can hold on. I messed up here. I apologize. We should end up with -1. Oh yes. No, it's +1. I am crazy, because you subtract 7 to both sides and then divide by -7, so that's going to end up giving you a +1. So I had an error when I was stating the answer, but then when I checked, I plugged in 1. So I may have written it down wrong. Alright, let's go ahead and take a look at example 3. So for example 3, we've got a lot going on. Alright, so when we're looking at this example, the first thing that I see is that we have a radical in the denominator that we cannot keep. So we need to go ahead and get rid of the radical in the denominator. The way that we're going to do that is we're going to go ahead and multiply both sides by the x minus 7 in order to get rid of the radical, the square root of x minus 7. Alright, now when we multiply by a radical, remember, life gets a little easier for us. Because a radical times a radical is just itself, okay? But also, when we multiply by the reciprocal, we cancel the fraction out. So on this side of the equation, it just becomes 21, sorry. But this simplifies down to just 1. Now, on the other side, we do need to distribute that square root of x minus 7 to both terms. Now, when I do that, remember the rule at the beginning of last lesson. If you have a times the square root of b, it becomes the square root of a times b. Okay, so whatever's on the inside is going to be reflected and multiplied. Alright, so with that, we're going to end up with the square root of x times x minus 7. So that's going to be x there. We can just write it out like this. X minus 7 for this step. We need to multiply the inside. Okay, and then plus, for this, notice how it's the same. So whenever it's the exact same, that's just going to be its number. So, or what's the radicand? Because the square root of x minus 7 times the square root of x minus 7, that's the same thing as saying x minus 7 squared. Okay, which would just end up being x minus 7. Okay. Alright, so we've got that sorted out. We do need to simplify this radical in order to isolate it and then also get rid of it. So I'm going to simplify on the inside. Square root of x squared minus 7x is on the inside. I'm going to subtract x over to the other side. And that's 7. That's going to become negative x plus 28. Alright. Now what we're going to do is we're going to go ahead and square both sides to get rid of this radical again. Or finally, however you want to say it. So on this side we're left with x squared minus 7x and then equals. Now we need to FOIL that out, which would just be negative x plus 28, negative x plus 28. First, outer, inner, and last. So negative x times negative x, it's just going to be x squared minus 28x minus 28x plus 28 times 28 is going to give me 784. On this side, we're going to be left with that. Okay, I'm seeing some x squareds. I'm seeing things on both sides. We need to go ahead and figure out if we're going to need to factor this. Okay, so I think this time I'm going to go ahead and start with my x squared because look, they cancel out. So if I know they cancel out, let's just go ahead and get all the x's on one side and all the constants on the other. Okay, so if I were to add these together, that would give me negative 56x. So if I add 56 to both sides, I would be left with 49 equals, this is all canceled, 784. Divide 49 on both sides. X is going to just give us 16. Alright, we are not finished though because our very last step is we do need to check our answer. So I'm going to do that in red. Check. Okay, so when we check our answer, we're going to substitute it back into our original equation. So the square root of 16 plus the square root of 16 minus 7 equals 21, all divided by the square root of 16 minus 7. So the square root of 16 is 4, plus the square root of 16 minus 7 is 9, which would give us 3. 21, all divided by the square root of 9, which again is 3. So 27 divided by 3, that just gives me 7 on that side and 7 on this side. So it does simplify out. Yay! 16 is an answer. If by all means you don't understand what in the world's going on with this, on the homework, you're welcome to go ahead and go to tutoring, and Miss Young or a tutor can help you out. I promise. You will not be left alone on this, okay? All right, last problem. I think problem 2 is going to be our craziest. Well, let's see what problems are not problems. Let's see what kind of crazy we can get into on this one. So the first step, remember, always with radicals, simplify and get that radical all by itself. So I'm going to go ahead and subtract the 5. We're going to end up with 21 minus 12x on this side equals 2x minus 5. The radical's isolated. We can go ahead and square both sides. And we're left with 21 minus 12x equals 2x squared. I'm sorry, not squared. I want to jump to the next step. Halfway. Okay? Because it's squared, you need to break it apart and FOIL it out, or do the box method, whatever you see fit. Here we go. We're going to end up with 4x squared minus 10x plus 25. Now what we're going to do is we're going to go ahead and get everything on one side. I'm noticing that I'm going to have an x squared, and it's not going to go away on this one, so because it's not going to go away, I'm going to go ahead and get everything, this over to the other side. So I'm going to add 12x to those x values and subtract 21. I would be left with 0 equals x squared equals, not equals, sorry, negative 20 plus 12. Negative 20 plus 12 is just going to give me a negative 8x plus 4. Okay, so at this point, I'm going to double check. Hey, you may have realized it before I did, but I rewrote the problem wrong, and that's human. So at this point, I noticed that this 21 should have been a 22. And if you're freaking out in your seat right now and you're trying to get the attention of whoever's covering the class, I'm so sorry. Okay, this is supposed to be 22. We are going to subtract 22, so that's going to change our final constant, which is 3. And it's going to be a positive 3. So that should be the correction on that one. So it should be 4x squared minus 8x plus 3. Now, the next step we're going to go ahead and do is we're going to go ahead and see if we can factor this out. Let's go ahead and see AC method. AC, 12. Are there two factors of 12 that are going to go ahead and multiply to give me 8? In this case, yeah. It's 2 and 6, but we got to play around with it because remember we need a negative here, or a positive here, and a negative in the middle. Let's see if both negatives will work. Yep, negative times negative gives me a positive, and that'll add up to give me that negative 8 I need in the middle for the B term. So we're going to go ahead and split that middle. So it's going to end up being 4x squared minus 2x minus 6x plus 3, and we're going to go ahead and factor by grouping. Okay, so go ahead and pull out or factor out a 2x from the first two terms. So that's going to end up being 2x minus 1. And on this side, I noticed that I'm going to end up, whoop, I forgot the x. And then that would just be 1. Okay, so then looking at negative 6x and 3, what I can factor out of both of those is a negative 3, because what's left on the inside, I need it to be negative. That middle term needs to be negative. or that middle sign for the constant needs to be negative. So if I factor out a 3, I'm left with 2x minus 1 as a binomial. Now looking at this, both sides have 2x minus 1, and I would be left with, once I factor that to the front, 2x minus 1 would be left with 2x minus 3. Oof, still not finished. We need to go ahead and set them equal to 0. So when we set those equal to 0, I'm going to move over to the other side for that. And we're going to have 2x minus 1 equals 0. And then we also have 2x minus 3 equals 0. Add the 1 over to the other side, you would end up with 2x equals 1, x equals 1/2. Okay, then we end up with x equals 3 because I add the 3 over to the other side, x equals 3/2. What we need to do next is we need to go ahead and check it. So when we check both of these solutions, we're going to go ahead and put it in the original equation. Let's see if I can do that over here, or at least one of them. So we're going to check 1/2 first. So it's the square root of 22 minus half of 12 is going to give us negative 6. Plus 5 equals half of 2 is 1. Now 22 minus 6 is going to give us 16 plus 5 equals 1. So that's going to be 4 plus 5 equals 1. That does not work because that would be 9 equals 1, and that's crazy. So I know for a fact x equals 1/2 does not work. I can tell you right now I'm not going to have room over there, so I'm going to go up over here. And the other value of x is x equals 3/2. So I'm substituting that in. Square root of 22 minus 12 times 3/2 plus 5 equals 2 times 3/2. Okay. Alright, so when we're doing fractions and we're multiplying them out, just remember that you need to take the numerator and multiply it by the whole number. I went to go get my calculator real quick. Didn't really need it, but I don't know, felt like I needed it. Okay, so 12 times 3 is going to give you 36. So that's going to end up being 36 divided by 2, 22 minus 36 divided by 2, which is just 18. 22 minus 18. Okay, and Josie, that's going to give us 4, so the square root of 4 on one side, plus 5, that's out there. And then we end up with 2 times 3, which is 6, divided by 2, which is just going to give us 3 on the other side. So that's 2 plus 5, which is 7, equals 3. That does not equal. So the answer for x equals 3/2 is also not a solution. So don't get tricked and just be like, oh, well, if 1/2 isn't the solution, then it has to be 3/2, because you could have no solution, and that may happen. All right, so that concludes this problem. There's really no solution, and that's what you would write, because we would end up with 2 extraneous solutions. And that is it for this problem. All right, have a wonderful day, and I'll see you guys at some point. Bye.